and it says 280, and I get off, and I get on, and it says 280, and I get off, and I do this 100 times, and every time I get on that scale, it says 280. Is that scale reliable?
No.
Yes, it is.
Thank you.
Reliably broken.
It's reliably broken.
Okay. Now you're thinking. It is reliable. Yes. Because every single time I get on, it tells me I weigh 280 pounds. But your initial thought was, no, it's not reliable. This is validity. Okay? If I get on and it says 280 every single time, it's a reliable scale. It is very consistent time after time after time. But if I get on and it says 280, I please hope everyone knows that that's not valid for my height and stature. Okay? So that is a really easy way to remember the difference between validity and reliability. Okay? Now, let's think about this a little bit more. Can a test or a measure be reliable and not valid? Yes. Can it be valid and not reliable?
No. Get it? I'm thinking of, I just went through my M-class data.
Okay. And it came out with no.
Yeah.
All right, let's think about this for a second. This time, we're looking at it as if we're throwing darts. And so, now we know reliability is consistency and validity is accuracy. Okay? So,
I like that.
In this case, it's unreliable and unvalid.
Can you say it again?
Right?
Say that again.
Can you say that again? What you that?
Validity is what?
Okay. Validity is the accuracy. Does it measure what it says it measures?
What's the other one?
The other one's reliability, and that's consistency.
Got it.
Okay.
So if you think about the scale, if I get on and off every time, and it says the same thing every single time, it's reliable. But if it's saying 280 every time, Pat, do I weigh 280 pounds?
No, you don't.
Never.
I don't know, do you?
Do I look like I do?
No, you don't.
All right, thank you, ma'am. All right. So now we're going to look at it similarly as if we're throwing darts. Okay? Now up here, this person is throwing darts over and over and over and over, but never hitting the target. So he or she lacks accuracy, right?
Yeah.
So also, she's not hitting the same spot every time. So it's not reliable either. Okay? So this is unreliable and unvalid.
Okay.
And is the word unvalid in statistics instead of invalid?
We're just going on right now.
Okay.
But no, I get your question. I'm just doing it. No, we say it's not valid.
Not valid.
Not valid.
Yeah.
Okay.
And we don't say invalid because that's
A different
an
kind of
absolute. Yeah. So we say it's not valid.
Okay. That's
Okay. I know it's a little, but thank you for noticing that detail. But I'm just going with right now.
But no, it's good because nothing's absolute.
Right.
Okay.
Sure.
Nothing's absolute in stats. Then we have this person over here who
Get it one time.
Getting it.
hit it, right?
Well, only hit the bullseye one time.
So, valid, at least once, but not reliably valid.
That would be me.
So, down here we have, boy, they are hitting the outside of that target every time.
Just a second if you don't mind.
Sure.
So the reason why the top right is valid is because of the one.
That's right there in the center. Yep. Yep. It measured what it intended to measure. It hit the mark one time. Okay? Now down here we have someone who's consistently not hitting the mark. They're measuring something. If we think about this in terms of measuring, they're measuring something, but they're not measuring what they intended to. So they're consistently hitting something. move the target over, it would be this, reliable and valid. Now, think about measurement in statistics. So you send out this test to 150 people, and it gives you back results like this. Is that good?
This one in the middle. I don't know.
Well, you would like this one in the middle.
Right.
Yes.
But not.
That's
not
not that one.
No, you don't want that.
Is this even measuring anything?
No.
It really isn't.
Well, it's going somewhere, but it's not.
It's all over the place.
Yeah.
So, back to my question before, can it be reliable and not valid? Yes. But if it's not valid, then it's not really reliable either. Okay?
So it's measuring something, but you don't know what.
Right.
It's not
So
really
it's not
reliable.
useful to you.
So,
It's,
right.
in your statistics, it's not useful to
Then
you.
it loses utility,
Yes.
not reliability.
Oh.
Right.
Okay.
So it would be, so going back, it can be reliable and not valid. But if it's not valid, then there's no way it can be reliable. There's no way it can reliably measure what you want it to. Okay? We good with that? Yes.
How do you know in the second one that, even though it hit the mark just once, I mean, if it's unreliable, then it doesn't matter.
Right. Because it didn't measure anything that's of value to us. Right? So it was valid one time. Which makes it valid because it did.
But how would you know that it's valid?
Well, that's a really good question. That's a
How do
really
you know
good
that's not a
question.
mistake?
So let's talk about that, okay? Because unfortunately, when we're talking about research, it's not just clear cut. The chart, you know, your statistics machine doesn't pop up with a target and let you know exactly like this, right? So what we do are these fancy statistical tests. This one in particular is called Chromebox Alpha. And this gives you reliability. And what it's doing is it's looking at the relationship. So remember how when you took the MSLQ, you basically had, there were 4 or 5 things that you answered, 4 or 5 items, and those 4 or 5 items make up each factor that we looked at, right? So if all 5 of those are highly related, not so highly as to be exactly the same thing, but highly related, then we can say that the reliability is pretty good, okay? And then we'll talk about validity here in a few minutes. Can you wait on that? Okay, we'll stay focused on reliability right now. So does everyone understand what I said about that? So if you recall, we had for intrinsic goal orientation, we had items 1, 16, 22, and 24. Remember how we put those together to see if they were reliable? Well, all 4 of those items were designed to see what people's intrinsic goal orientation was, but it took all 4. If we just had one item, we'd have no idea whether or not it was a reliable measure, okay? So because the relationship was 0.712, we can say that's pretty good, okay? Chromebox Alpha, there's kind of a scale. So this is sort of one of those givens, like whenever you look at a Chromebox Alpha in the future, you can go to Wikipedia and get this same table. They have it there as well. But since our answer fell right here, between 0.8 and 0.7, it's acceptable. Okay? Now, just to let you know, the Motivated Scales for Learning questionnaire is it has to do with beliefs and values and things that are internal to individuals. And so when we get into these psychological type measures, there's a little more flexibility. When we come around 0.7 or above, we're doing pretty good in terms of the psychometrics. Now, we want reliabilities that are a little bit higher if we're talking about student achievement, right? be reliable, 70% of the time, or to have a relationship of about 70%. Not real exciting, right? We want it to be higher for achievement tests and things like that. But the reason that this is in the acceptable range is because it has to do with beliefs and values. In achievement, you really want to be shooting for high, good, or excellent in terms of the reliability. So that's a table. If you just look up Chromebox Alpha on Wikipedia, you'll get that table, or you can refer back to these notes. You'll have access to this class for the rest of your time here. So if you don't do quantitative and this is all you get, and you're sitting down to do your dissertation and you're like, oh heck, refer back to these slides, okay? So in control of learning beliefs, if we look at that one, and you would have this in your data that in your output file. So if we look at Chromebox Alpha at 0.75, it's acceptable. Pretty good for a psychometric measure. Okay? So, these are questions that whenever you go to find instruments, that you should be asking yourself. So, in thinking about basically I'm trying to get you to come at reliability with a little bit different mindset, okay? Yeah, I'll let you go back and look at these. So now, validity. We already know this has to do with accuracy. It's the extent to which an instrument or procedure measures what it was intended to measure. Okay? Did it hit the target? Did it hit the center? Did it hit what it intended to hit? That allows you to make appropriate inferences. So in this case, 280 pounds for this person right here, valid or not valid? Not valid. Good. So this goes back to your question. How do we know it's valid? All right? So one way to know that it's valid is to do content validation. And this is where you get experts in the field and you send them your questions and you say, do these things measure X, Y, Z? So for example, I was in developing an instrument, well, how about the group when they developed the Motivated Scales for Learning questionnaire? They went to all of their professional colleagues and said, do you think that this measures intrinsic goal orientation? Do you think this measures, and they give them the definition of what that is, and they rank it. And it's a pretty involved process, but it can be as simple as just asking. But really, for content validation, typically you would go to experts in the domain. Okay? Now, if you're doing a, yes?
Are we going to be expected to do that for our dissertation, go to experts about our particular question? Or is it going to be
that's
our
a good
dissertation
question.
committee?
That's a good question. In most cases, your committee will help you make that determination. It may be that the folks on your committee, depending on what kinds of questions you're asking, have that expertise, or they may ask you to contact some people who have that expertise. But you'd be amazed how many people are willing to help people working on their doctorate do things like that, validate surveys and stuff. And ideally, you would not necessarily come up with your own survey. You would use one that already exists, okay? Because there are people who spend their lives. I mean, to create a survey like the MSLQ, that was not something that he sat down one night and said, here, this is what I think these stems are. They sat down, this was a group of people working, and they probably spent 2 or 3 years validating it and doing the reliability on it, okay? So it's truly a really involved process. But to some degree, content validation is an important process and one that you'll probably go through to some extent.
Thank you.
That was a long answer for your short question, wasn't it? Another form of validity is predictive validity. and this predicts future performance in a particular domain. So, does what's being measured now accurately predict your potential to do well in mathematics, for example? Okay? Predictive validity kind of goes back to the GRE and the SATs. You know how whenever you do those tests, those standardized tests, and there's like 5 tests, but one doesn't count, you only get scores on 4, but they don't tell you which one it is?
Field testing.
They're field testing. They're doing the validity and the reliability. They're saying, first they're saying, does this, and in this case it would be content validity. They're saying, does this test measure, or does this test score resemble the test score that this same student got on a similar test, right? So do those scores match? That's the validity. And then the reliability is it consistent across numerous students? So if student A, this is going to require a little poker marker on my part. So if student A had a hot, I'm just going to make up numbers. Student A has a math of 120 and then does this extraneous test, and it was math. And when I say extraneous, it's not extraneous, it's the extra one that doesn't get credit, and they get a 119, they would say that the content validity is probably accurate. Okay? And then when you get to student B gets a 130 and a 132.
Yeah, pretty good.
And it's also reliable because now it's saying that the difference between student A and B is consistently different.
I don't want them to actually learn something.
So that's how we get to figuring out if it's valid or not. Okay? And usually whenever you're looking for measures, they're going to go into a big long process of talking about the different ways they validated it. But I don't want to go too far into that stuff because right now, aren't we feeling really confident about statistics right now? Frighteningly so. That's what I like to hear. I want to make sure that when you walk out of here today, you're still feeling very confident about your statistics, okay? So, when we're talking about, you can ask yourself, does the instrument tap into a representative sample of the construct or characteristic being studied? Is it hitting that target that I want to hit? Is another way of saying that same question.
And validity is a place where I think understanding both qualitative and quantitative research is really important because you're going to get, well, I'll just say it, never mind, I don't have the time, or I can't think through the process of asking this as a question. When you're putting together a survey, I'm still out of it today, guys, sorry. When you're putting together a survey, you have to use words to operationalize what it is you are studying measuring through your quantitative methods. So, this is where qualitative research actually has or at least qualitative sort of methods in the foundation can have a real impact on the quantitative research that you're doing. If you ask the right question, you get the answers that you're looking for.
Right.
But if you ask the wrong question, that's where you might get reliable data that's not valid because you're asking something different than what is actually being answered by the respondent. Okay, so it's just something important.
Yeah, no, I agree. Thank you.
But qualitatively, if you're asking a guiding question to get an answer that you're looking for, do you lose validity in that assessment?
Doesn't it control your biases?
Well, yes, you're going to get bias, right?
But I'm quite naive on qualitative. So I'm thinking if I come up with a survey of 10, 15, 20 questions asking people about their study skills, and I'm like, do you study more often on Fridays? Fridays do you study the most? On Friday, when do you study the most? At what time on Friday do you
Leave
study?
it
So,
there.
like, and then all of a sudden my survey goes, Friday is when students study the most. And I have this very reliable assessment of looking at when students study on Friday. But I'm asking these qualitative questions that might skew the quantitative results. So do I lose validity in that assessment?
It depends on what you want to know.
Right. If you want to know about Friday, then
Yeah.
you're in a good place.
Well, but I'm thinking about some of these surveys that come out that try to make these overall assessments of these are people's beliefs and ideas, but the questions are these have, not have nots, these double negatives, and then all of a sudden it's kind of like, well, wait a second, we've led this person this way, so
Right.
how valid is
It's
this
leading to
research
witness.
actually?
Well,
Not leading to
that's what you
witness.
should be
It's
asking.
leading to
Yeah,
witness.
that's
It's so confusing that you can't understand what they're asking
Right.
you. It's
This-
leading to witness.
This is why, I mean, I don't want to get into survey
Yeah,
design
it's
and
fine.
development, but, because that, I mean, I took at least one whole class on
I did
survey
too
design and
on the
development.
quantitative side.
Yeah. I mean, everything, including your scale, right, is you're influencing that response. Do you include 4 or 5? Do you give them an out? Do you not? Do you have a midpoint? How do you word it? Do you say, extremely likely, very likely, highly likely, like all of those? That's where I'm sort of saying, like, understanding the bias that comes in that we welcome in some ways in qualitative research has an impact on quantitative research that's supposed to remove as much bias as possible.
Okay.
And that's I think, something we often don't think about, the level of bias that's present in quantitative research, because we take these things we've operationalized and we reduce them to a number. But how we get to that number contains a whole bunch of bias. That's where you bring in researchers to review the questions that you're asking, and they can tell you, you know what, you're leading them in a direction away from answering the research questions.
Sorry if I got this straight.
I think that's a good conversation because because it helps to highlight not only the differences between qualitative and quantitative, but how important the two both are, and why we talk about mixed methods next in this class, because together they're stronger. I think that qualitative and quantitative inform each other, and together they're stronger. So.
Thank you.
So good question, actually. Another thing for you to think about, and this is sort of an aside and goes a little further, not survey design, but thinking about selecting surveys, maybe choosing to use someone else's survey. But you want to think about the expense of it and the ease of its use. So when you do get to a point where you're doing your own research, you're going to want to think about this very practically. If the survey is $10 per administration and you needed 100 administrations of that test, is that something that you're probably going to choose to do, or will you try to find a survey that measures something close and is $1 for each administration, or free, even better, free, right? Okay, so practicality is really important, and so these are some of the questions that when you get to that point where you're doing your own research, you're going to want to ask yourself these kinds of questions as you select your surveys. Where are we? All right. Where are we on time? We are good on time. All right. So now I'm going back and forth. Shall we look at t-tests and understand what those mean now? Are we ready for that? All right. First, I want to say all great achievements require time, and it's important to consider that the greater danger for most of us lies not in setting our aim too high and falling short, but in setting our aim too low and hitting our mark. Okay? Let's think about those things moving forward, and let's dive in. All right. So how many people are you and why are you there? Let me know. Okay. So looking at this sample report that we did, how many of you were able to come up with a report that looked pretty much identical to this?
Yeah.
Okay. Were you able to get your italicized with the subscript.
I can do it, I found the numbers, I found the A and the O, simple, but how do you make the numbers small?
So, how many people found this to be a very time-consuming, non-intellectual activity? Formatting it perfectly so that your D's were italicized, your table looked like this table, you had subscripts where there were subscripts. Now, when I say it's supposed to look exactly like this, I mean it is supposed to look exactly like this. And it takes a tremendous, I got some head nodding over there, he was successful. It takes a lot of time. You notice I didn't just give you the Word doc and let you just plug in numbers?
Right.
Right? Because this is a skill that you need to have.
Yeah.
And,
Sorry.
go ahead.
One hint, and this is something my professor showed me in grad school, and I do this for every time I'm preparing anything for publication. I prepare all of my tables in Excel. Excel lets you edit and do borders much easier, and it will copy and paste directly how you formatted it there into Word. And I found Excel is much easier to work in for preparing tables and then copying and pasting than doing it in Word itself. So that's a trick for the future.
That's really hilarious because you're the qualitative guy talking about using Excel, and I'm the quantitative girl that'll say, oh, no, tables and Word documents, I totally get those. It's much easier to do.
Yeah, because the column alignments stay
The column alignments are
Yeah.
need to be that good.
Yeah, column alignments, yeah.
I don't know what should it have been.
Is that times New Roman 12?
No, the table, okay, so this is APA, folks.
APA formatting, yes.
You have to format exactly like this. This is APA.
What, is that
Uh-huh.
Times New Roman 12? I mean, what's your font? Because I did Times New Roman and my table doesn't look the same as your font on the bottom.
This down here.
Or I didn't make it bold. Was I
It
supposed
looks
to make it
different in
bold?
that PDF than it does.
Than it does in a Word document.
Yeah.
Mine was Times New Roman.
And it was 12? Yeah, I did that and it just looked a little bit different.
Okay.
I don't know why.
So, but just so you know, this is your APA format, and this is the kind of thing that I think is very challenging in writing your dissertation. And I know I'm jumping to 2 years down the road or whatever, but I wanted you to go through this exercise because none of this had any meaning to you. You were just plugging in numbers and formatting, right? We can talk about what this means now, but I need you to understand that it just takes a lot of time, and these aren't the kinds of things you can leave till the end.
Well, I feel better already that was the purpose.
Yes.
Because I'm not 100% sure I understand what it.
Yeah, well, honestly, I might have set this up a little better if we had had the spring break and then so yeah. You've achieved your purpose if your thing looks like this, okay? Now, let's look at this guy right here. And I'm just going to use this one because we all have the same data, right? You may have chosen to do gender. Well, you should have chosen to do gender.
We did.
So I'll be looking for the right numbers related to gender, but for right now, let's just look at this. Now, let's look at self-efficacy for learning performance. My Levine's is 0.004. So should I look at my equal variances assumed or my equal variances not assumed? Oh, yeah, sorry.
For which one? For which one?
I know. So looking at my significance, I apologize, thank you. So 0.94, should I be looking at equal variances assumed or equal variances not assumed?
Assumed.
Where are you at?
I'm
the
on
one
the
she sent us.
independent samples
Oh, that's the
t-test.
one you
Yeah.
sent. Oh.
Yeah.
Said like why.
The one
And
she
this is
hired.
the one that you did with me on the video.
Yeah.
So you say equal variances assumed.
So the
Good.
directions says.
What about for extrinsic goal orientation? Okay, so equal variance is not assumed. Now we're looking at extrinsic goal orientation. We're gonna look at equal variance is not assumed because it's less than 0.05. Yes. Alright? That's all this Levine's test tells us. It tells us, should I be looking at this row of numbers or should I be looking at this row of numbers? That's all that test tells you. So now that we know that in this case we're gonna look at equal variance is not assumed, then we're gonna ignore this whole top row of numbers. Just ignore it. You know what I do when I have it? When I actually have the printout, I take a black Sharpie and I just draw right through it.
That's amazing.
Isn't it? Black Sharpie makes me very happy.
She just said that like right before you
I
said it.
said,
She
can you take a Sharpie and like just cross it out? Because why is it even there if I don't need it?
Because we didn't know if we needed it, right?
So which one?
We made that determination. Down here, we need that top row.
Well, then you don't, but you don't need the bottom.
So we don't need the bottom one.
But we don't want the computer making decisions for us.
Okay, fair enough.
Alright? Because when that starts happening, folks, we get robots taking over the world.
Absolutely.
Oh my gosh.
Let's not let the computer make decisions for us, okay? So now we're looking at this bottom row. And
Okay.
Which one don't we need?
right, because the significance, this one right here is less than 0.05. So, in the test, the t-test, it's comparing means. Okay? It's taking the one group of means and comparing it to the other group. And in this case, what was I doing? I was doing doctoral and non-doctoral. So we were looking at doctoral students versus non-doctoral students. Now, is there a statistically significant difference between my doctoral students and my non-doctoral students on extrinsic goal orientation?
Extrinsic goal orientation?
Yeah, on this row right
For the
here.
mean?
No.
it's not.
So we were talking about the t-test, this right here. And this is the significance of the t-test. And basically what the t-test tells us is we compared two groups of people. We compared doctoral students to non-doctoral students. And so the question is, are they statistically significantly different? And Carol says no. Why, Carol?
Has something to do with those numbers.
Okay. She's absolutely right. That is absolutely true.
It's not less than point.
That is right. It's not less than.
None of them are less than.
It's not less than 0.05.
It's not less than 0.05, correct.
Yeah.
Because if it's less than 0.05, that tells us that it's statistically significant. If it's greater than 0.05, then it's not. Now, if you think about this on 100% of the scale, on a 100% scale, right? So, if you have 100%, and it's, 0 to 100, and you say, 95% of the time, you're gonna be right. That leaves 5% over here. That's what that 0.05 is it's the 5%. It's your 95% confidence interval. Kind of understand it? A little bit? I'm gonna have to come up with some good visual because I'm not sure there is one. And this is not necessarily an easy concept to understand in my personal opinion. At some point, I just got 0.05 in my head and went with it, right? That's one easy way to do this. And it's fine if you do that. It's fine if you do that. But I do want you to understand, does that mean? No. Okay. I do want you to understand that when you say that it's, now I can't even remember which way to make my little sign. Yeah, if it's less than.
That's awesome. You totally get it. Awesome.
If it's less than 0.05, so we're saying that less than 5% of the time I'm wrong. Okay, that means that I can say comfortably that plus 95, at least 95% of the time I'm right. That's what that 0.05 is. So if it's less than 0.05, I'm wrong less than 0.05% of the time. Or 5%.
Based on your hypothesis.
Based on my hypothesis.
Okay.
Thank you for bringing me
Thank
back
you.
to accurate.
I just wanted to clarify, because I had a feeling that's where there was some. Yes,
Okay. Well, and here's the thing. It depends on also who you talk to. Because if you talk to my husband, pretty much 0.001 significance level. Okay.
But
Moving on.
We don't have high standards at
What
all.
field is he in?
He's in gifted ed too.
Oh, interesting.
Yeah.
Because in hard sciences we will find lower p-values because more air has much greater implications, right?
Yes.
If we're doing trials for a drug, we don't want to be wrong 5% of the time. We want to be wrong less than 1% of the time, or 0.1% of the time if possible. In education.
It was actually.
Oh, sorry. But we're dealing with greater opportunity for error.
Let's just teach wrong history. I mean,
Alright. So, but here's the thing, folks. I want you to leave here remaining confident in your knowledge of statistics. So, if it's less than 0.05, it's significant. If it's bigger than 0.05, it's not. And that's all you need to remember right now. If you take a quantitative course, they're going to talk to you at length about confidence interval. But that's more than we want to talk about tonight. Why? Because you just need to remember, less than 0.05 on the significance, it's statistically significant. More than 0.05 and it's not.
And which column are we talking about?
The one that says significant two-tailed.
So it's two-tailed because there's a top and a bottom to it. Sorry.
The T distribution looks sort of like a normal distribution, and these are our tails.
Oh, okay.
So those are two tails. That was a good question, actually. Yeah? We good? So that's kind of really all you need to know. So let's go back to this file right here. I didn't have you guys write a null and a alternative hypothesis, did I?
Yes.
Yes.
Oh, I did. Okay, but did you, when you came up with your, oh, I did give you directions for writing your hypothesis. Good. Okay, so does everyone understand the null and the alternative hypothesis?
Yes.
That was pretty straightforward. Okay. So, the T statistic, is everyone still feeling confident about their stats knowledge?
We never felt confident, so still doesn't.
You did too. A few minutes ago, I asked everyone and everyone was like, whoop, whoop.
Could you briefly review the null and alternative hypothesis?
Sure.
Briefly, please.
Let's. Okay, so the null hypothesis, basically you first you start with a question. That's what I like to do. Is there a significant difference in control of learning beliefs between doctoral students and non-doctoral students? So my two groups are doctoral students and non-doctoral students. Okay? Is there a significant difference So the null hypothesis is saying, no, there's no significant difference. And you just make that statement. My null hypothesis is there is no significant difference, and you're basically restating the question as a no. Your alternative hypothesis is your alternative to your null hypothesis. In other words, you're saying, yes, there is a statistically significant difference. And so that would be your alternative hypothesis. Okay? So, in this case, there was no statistically significant difference. Why? Right, because my significance level, my P, was greater than 0.05. And this goes back to what I showed you earlier, where they start adding levels or letters, and it seems really random. P is always going to be your statistic, your significance level. So that's so looking right here, it's the significance level. So when you're reporting it, that's your significance level, and that comes from this column right here, the significance column. Why do they change it to a letter? I don't know, just to make it challenging for us. I've never known. Yes?
It's probability of it not being due to chance.
Oh, you're right. I guess I did know at one point.
Is it time to vote somebody off the island? I'm just asking.
Who do you want to vote off the island?
We can look at the statistics of.
But it is a measured probability. So thank you for that. Into the accuracy. He's bringing a high level of accuracy to our discussion. Effect size, it's a D because it refers to Cohen's D. If that's effect size. You know how to calculate that? Yes?
Yes.
Where'd you get the 0.82 from?
0.82? Okay, so in this instance, for this one, we were looking at control of learning beliefs.
Yeah.
Okay?
Here
And
here.
so when I went here, I went to control of learning beliefs. I went to right here, because the significance here was, so I chose to look at this row. Oh wait,
That's right.
okay. See, I always lose track of my thinking when I'm like in front of people. And I rounded to 0.82.
Yeah.
So it was simple rounding. And I pretty much always round to 2 decimals when I'm reporting out, even though SPSS gives you 3 decimals, or as many as you tell it, but usually. Okay, so there's 2 tests. The first one is Levine's, which tells you should I use this or this. If it is greater than 0.05, then it is equal variance is assumed. If it's less than 0.05, am I saying that right? Yes, equal is not assumed. So since this one was greater than,
Use equal variances.
but I wanted to show you doing it right. But here's the thing, guys. Are you going to remember this?
No.
Some people are, but he's been voted off the island. So you may not remember this. Where are you going to go to get this information?
Your notes.
The notes that have been provided for you? If it makes you feel any better, if it makes you feel any better, I know how to run hierarchical linear models. Groups within groups within groups within groups. And I still go back to my notes to remember which Levines I'm supposed to use. I mean, I just do. I always double check myself. You're going to do the same thing. You're going to have to go back to these notes.
If you want a really good book, get Statistics Without Tears. It's on Amazon for like $5, and it breaks all this down.
You're going to try and put me out of a job?
No, I'm going to try to help supplement your job.
I'll write that down. Maybe that's a book I want to look at for this class.
I'll bring you my copy. It kept me from crying through.
Alright, so, how are we on t-tests? Do those numbers make any sense at all?
Yes. Me too.
Do you know where they come from and why they come from there? Do we know why Levine's test is different than the t-test? Okay, what does Levine's test do? It only serves one purpose.
Assumed or not? Yes.
Yes. Okay, that's all Levine's test is good for right now. Okay? That's all it's good for right now. Then what we're concerned about, once we just figure out which row, you could also, if you wanted to, you could cross out the Levine's test once you figured out which row. Okay, because we're not going to use Levine's test once we figure out whether it's equal variances or unequal variances. Then we come over here, and then what we're concerned about is this t-test information. Our t-statistic is, it's basically a number from a distribution. Not unlike a normal distribution, but not a normal distribution. So, not that important, it's just a t. What's your t? People will ask you, what's your t? And you can tell them it's whatever. The number you're most concerned about is your significance.
And if it's less than 0.05, you're gonna go down to the second row. Correct? Not
It's,
correct?
yes, that's correct.
Okay.
I wanted to double check so I didn't tell you wrong.
Okay. If you didn't have the significance term, could you chat it by just the T number, or do you?
Then I would need a table. And in the old days, the stats books would all have these tables in the back of them that would tell you what T number was significant and at what level. So, yeah, no, I wouldn't, but yes, if I had a book, I could. In this case, I let SPSS tell me. It's basically putting the table there for you. And in the olden days, it was not that long ago. Did you ever have to do that?
Yes. Yes.
And like I said, I'm gonna let your quantitative teacher talk to you more about the 95% confidence interval. Because right now, everyone who's walked out is gonna leave here and they're gonna be like, I got this, right? And I did really well on all of this. And I did really well on this. I might have felt like that for a minute. But I still did really well on it. Okay, there's one last thing I want to show you. Can we handle one more thing?
Sure. And keep confidence? I don't know. Copy time.
Are there any more questions about the t-test before I go to the next thing? No? Good? Okay. So the last thing that I want to show you is how to find an instrument like the MSLQ. Are we ready? Okay. UNCW Library. Go to articles and e-resources, just like you normally would. I still go to the EBSCO host, or whatever that's called. Because then it pops up a screen that lets me choose my database. Remember going through this process? Alright. I don't care about academic search complete. I don't care about any other thing except for JKLM, the mental measurements yearbook. And this is a repository of surveys. I want to, and these, just so you know, it does a lot of things, like it'll do teacher perceptions. Well, let's look and see if we can find one on teacher perceptions, because that might be a topic somebody's interested in. Or teacher attitudes, did you see that pop up? The third one down? Attitudes, you have to spell it right. And here are all of these different surveys on test of attitude toward school. A teacher attitude inventory, identifying teacher positions in relation to educational issues and decisions. Now, here's the problem. In many cases, it's not free. And what you're going to get here is a review. Oh, actually, let's go to the HTML. But the really cool thing is this, you asked before, how do we know if it's valid? Well, if we want to know if this is valid, it'll talk about validity in here. It talks about the different factors that it, let's see. So this one measures, should have done one that I was really familiar with. Where are you seeing that? It would be a common one, and you could probably do a search for teacher self-efficacy. Okay. But it'll tell you all the factors that it's measuring, which this one's strictly attitudes. It's not looking at, it doesn't seem to be looking at additional factors. Oh, controlling versus releasing, rigidity versus flexibility, individualism versus group orientation, interest versus disinterest in professionalism. Yeah. So this is a huge, wonderful tool for you. And what I was going to do...
Well, you said you were going to show us where we might see where it was free or what it would cost.
Oh, no, it doesn't tell you that.
Oh, how do you find that out?
That's a good question. Typically, you can go to the authors or you can go to the copyright. Another way to do this is to, so we know that the way that I usually do it,
Go to YouTube. See a video quiz.
do a Google search. Oh, it looks like it might be available. Yeah.
Well, there.
So,
Liability.
well, Eric used to be funded by the government, and they pulled the funding in, I'm not sure, I want to say it was 95. And once the funding was pulled, people quit putting stuff up there. So there you can find the book, and then it provides you with related instruments. So do you see how I'm using multiple tools? Okay. So what I wanted you to do, you have 10 minutes, is activity number 4. You're going to go to mental measurements, and if you just get into mental measurements, you're doing good. But try to think of a topic that might be related to your